So right now, if we middle mouse, we have our rest XYZ and rest 2 XYZ. They each have about 56 million voxels, and it's taking up 1.48 gigabytes on disk. So most of this memory is happening because of our rest fields. And this is probably the biggest critique that rest fields get, because you don't want this many voxels happening with every single frame. It's just going to take a lot of RAM. It's going to take a lot of disk space. It's a very, very inefficient way of simulating. Some of this is unavoidable because of the fact that Houdini still has not created a VDB-based Pyro solver. They're still working with the antiquated volume fields right here. And so unfortunately, you can't get rid of a lot of this voxel count right here, but there are things you can do to help it. So in the DOPNet, if we go in here, if we go to our rest, instead of setting the division size to 0.05, you could set this to anything you want. And we're trying to just get position, which doesn't need to be a super high res bit of information. So we can set this to, let's say, 0.1 as an example. And let's see what that did to our memory. Well, I can tell you right now that it made a massive impact. If we middle mouse here, we're down to about 8 million voxels. And our memory is only 410 megabytes. That's less than a third of the size in just that one thing right there. So now I'm going to take this even further. Let's say that I create a volume visualization and I set this to rest.x as the density field. So what we'll see is that all of these position values are being stored, even if it's outside of the plume. And that's a lot of space that we really don't need. So I don't need to calculate the rest position in areas that we don't have smoke. It doesn't really matter. And we can trim that down by quite a bit. So first things first, VDB combine. There is an operation in here called the activity intersection that we can use to help us out. First of all, make sure that this is all converted to VDBs, and then take the density in isolation. So we will delete everything except for density. So delete non-selected. And for testing purposes, I'll do the same exact thing for rest.x. Rest.x is going to go in the first input, and in the second input, we will use density. So we'll just kind of switch these guys around right here. There we go. Okay, with the activity intersection, watch what happens to rest.x now. So I'll go ahead and create another volume visualization, and we'll say rest.x. Now we've trimmed out the areas that we don't need. And if we take a look at our voxel counts, we just went from 7.4 million down to about 1 million. So that's 7 times less memory just with that one operation. Okay, so that's really awesome. Now, how do we do that for all the rest fields? Let's take a for each primitive. And instead of feeding in our rest.x right there, we can just feed in each single primitive and delete density before we bring that into the loop. So in other words, what we do is we take this guy, bring it on down. That's going to be the input right there. We want to get rid of density so that we don't do that to density. And then we take our results right here. And so if we do that for every single primitive, let's see what we get. So we don't have rest.x right now, and that's because we need to switch this over to delete selected. Okay, and this is our rest.x. If we have rest.y, we're also trimming that off nicely. And we can also double check this with the volume slice as well. And so if we take this with the volume slice, it doesn't look very good, but if we turn on the marker and zoom in here, we can see that this data is being preserved. So that's all good. Okay, great. Now let's bring this in with everything else. So we'll then use this VDB vector merge to bring in all the vectors into one field like this. And we also want to use a deactivate right here, and that will save us a lot of memory as well. So we brought this down, when it's all said and done, to 63 megabytes. That's amazing. And this VDB resample is really good too if you want to, let's say, up-res or down-res, that is, the velocity in the flame. So if you don't need that much data coming in for those two guys, you can do that. I'm not going to do that for flame. I'll leave flame at the 0.05. So that's good right there with all that detail. But wow, what a major difference that is. Now, let's not forget to bring back our density here. So we will create another delete right here, density, isolate that, and we will merge it in with these guys. All right, so when it's all said and done, we have 237 megabytes. We merge the vectors here. That brings it down to about 230. We then change the data here to 16-bit floats. We resample, in this case, velocity down to 0.1. We don't really need a huge resolution for that because it's just getting used for motion blur. So we downsize that a little bit, and then we also deactivate any voxels we don't need. And that leaves us with about 133 megabytes, which is, I think, about 10 times more efficient than what we had before. So, and actually we're not even done because that goes down here to create the combined rest position. We delete both rest fields, and now we end up with about 115 voxels, which we can turn down even more if we want to go aggressive on the voxel size with the combined rest position. So if we want to do 0.15, then yeah, we're already down to about 335,000 voxels, and we're at about 100 megabytes. So that's really, really awesome. And this is why it's so important for you guys to go through every single field and ask yourself if things can be optimized. In the next video, let's apply this to our smoke.